Hi students, I am Srinivas Sadri. On behalf of Narayana Educational Institutions, I am going to explain the solutions for Physics JEE Mains question paper which was conducted on 24th of January afternoon. So let us look into the questions. This is the first question. N equally spaced charges, each of a value q, are placed on a circle of radius capital R. The circle rotates about its axis with an angular velocity omega as shown in the figure. A bigger Amperian loop B encloses the whole circle, whereas a smaller Amperian loop A encloses the small segment. The difference between the currents IA minus IB for the Amperian loops is dash. So we are going to calculate the currents for IA and IB. When I consider the smaller loop, the equivalent current that is passing through the Amperian loop A is given in this manner. So the equivalent current IA will becomes equals to the net charge flowing. So for one revolution, the total charge flown is equals to NQ divided by the time period. The time period is going to be 2 pi divided by omega. So this is going to be NQ omega divided by 2 pi. Whereas when we consider the loop B, because there is both outgoing as well as incoming currents, the effective value of current passing through that one will becomes equal to 0. So according to the question, IA minus IB will becomes equals to NQ omega divided by 2 pi. So it is going to be the option 1. Next question. Let us go to next question. The next question is here. In photoelectric effect, the stopping potential V0 versus frequency nu curve is plotted. H is the Planck's constant and phi naught is the work function of the metal. So here they are asking, they have given five statements and we have to choose the correct out of these 5 statements. So these are related to the graph. So first of all, let us draw the graph related to this particular equation. Because it is related to stopping potential and the frequency of incident light, we are going to use the Planck's equation, which is given by h nu is equals to the work function phi naught plus E into V naught, where V naught is the stopping potential. So now from this equation, I am going to write the equation, a relation between V naught and nu as V naught is equals to h divided by E into nu minus phi naught divided by E. So if you look at this particular equation, this is in the form of an equation y is equals to mx plus c form. So when we plot the graph here, it's going to be a straight line in this manner. So I'm going to take frequency nu on the x-axis and the stopping potential V0 on the x-axis and the y-axis. So the graph is going to be something like this. Now this point where the line is going to intersect with the x-axis, this is going to be the threshold frequency nu naught. The y-intercept here will becomes equals to minus phi naught divided by E. The slope of this particular graph is equals to h divided by E. Now let us look into these particular statements which are given. The first statement says that V0 versus nu is a linear graph. Of course, we got a straight line. So option, this statement A is going to be correct. Next one, the slope of V0 versus nu curve is phi naught divided by h. Whereas if you look at the graph, the slope is h by E. So this statement is going to be wrong. Whereas statement C, H constant is related to slope of V0 versus nu graph. Of course, it is related to the slope. So options, the statement C is going to be correct. The value of electric charge of electron is not required to determine H using V0 versus nu graph. So if you want to calculate the value of H, we need the value of E because the slope is equals to H by E. So the statement D is going to be wrong. And the last statement, the work function can be estimated without knowing the value of H. Of course, the y-intercept is minus phi naught by E. Without knowing the value of slope, we can calculate it. So the statement E is going to be correct. So if you look at all the options, the option 4 is going to be more appropriate. 28th question. The magnitude of heat exchanged by a system for a given cyclic process ABCA in the figure is, they're asking in the SI units. So if you look at this one, there is a cyclic process. The cyclic process is starting from A, B, C to A. So in any cyclic process, if you are considering the change in internal energy, the total change in internal energy is equal to 0. Because there is no change in internal energy, the magnitude of heat exchange, they're asking only the magnitude. So magnitude of heat exchange should be equals to the magnitude of work done in the process. When it comes to the magnitude of work done in the process, it should be the area enclosed within this cyclic process. Because there are two different quantities which are along x and y axis, it is equivalent to an ellipse. So this area is going to be half of the ellipse. So it should becomes equals to pi AB divided by 2. So this value of magnitude of change in heat energy is going to be 1 by 2 pi by 2 into A. A is the length of the semi-major axis, that should becomes equals to, on the x-axis you have to understand that the units are given in cc. So the value of A is going to be 200 divided by 2, because it is given in cc, converting into SI system it should be into 10 power minus 6 into B. So on the y-axis, the difference is given as complete, in taking the complete circle, the difference is nothing but 200 kilopascal. So that should becomes equals to 200 divided by 2 into 10 to the power of 3, converting into pascals. So now on simplification, here this will go 100 times, here also 100. So this value is going to be now delta Q, mod delta Q is going to be 5 pi SI units. So it's going to be option 2. Next, 29th question. In Young's double slit experiment, three polarizers are kept as shown in the figure. The transmission axis of P1 and P2 are orthogonal to each other. The polarizer P3 covers both the slits with a transmission axis at 45 degrees to those of P1 and P2. An unpolarized light of wavelength lambda and intensity I naught is incident on P1 and P2. The intensity at a point after P3 where the path difference between the light waves from S1 to S2 is equals to lambda by 3. So here this is a question which is involving two concepts. One is the light coming out from the polarizer, the Malus law, and next one is they're asking the condition for the maximum, the condition for resultant intensity. So because P1 and P2 are given as two polarizers and the light incident on them is equals to I naught, the light coming out from each of the polarizer, either P1 or P2, if I imagine that the intensity of light coming out from the first polarizer P1 is equals to I naught is the incident light divided by unpolarized light. When it is incident, the polarized light will have an intensity which is equals to I naught by 2. Whereas the intensity of the plane polarized light coming out from the second polarizer is going to be I naught divided by 2, because I naught is the intensity of light which is incident on both of them. After this polarized light, it is passing through the third polarizer P3. When it comes to the transmission axis, it is given very clearly that the transmission axis of the polarizer P1 and P2, they are perpendicular to each other, whereas the transmission axis of the polarizer P3 is making an angle 45 degrees with each of them. So for the light coming out from the polarizer P3, if I imagine the intensity is as I1 dash due to the light coming out from P1 and I2 dash as the light coming out from the polarizer P2, then according to the Malus law, I1 dash will becomes equals to I0 divided by 2 into cos square 45. So this value is going to be I0 divided by 4. Whereas the intensity of light coming out from P3 after it is coming out from P2 is given by I2 dash, which is again equals to I0 divided by 2 cos square of 45. This value is going to be I0 divided by 4. Now these two lights, they are having a path difference at a certain point, and the path difference is given, that is equals to lambda by 3. So at that point the phase difference will be given by delta phi is equals to 2 pi by lambda into, because the path difference is nothing but lambda by 3, this path, the phase difference will becomes equals to 2 pi by 3. So due to these intensities, the resultant intensity will be given by I is equals to 4 times of the intensity of light coming out from P3 due to the light coming out from P1 and P2 are equal, and that value is nothing but equals to I0 divided by 4 into cos square of delta phi divided by 2, that should becomes equals to pi by 3. So cos pi by 3 is nothing but 1 by 2. So 4 and 4 will get cancelled. The resultant intensity will become equals to I naught divided by 4. So it's going to be option 4. Next question number 30. A long straight wire of circular cross section with a radius A carries a steady current I. The current I is uniformly distributed across the cross section. The plot of magnitude field B with a distance small r from the center of the wire is given by. So we know very well that the value of magnetic field induction at a distance small r inside a uniformly current carrying conductor is given by B in is equals to mu naught I small r divided by 2 pi capital R square. Capital R is the radius. So field at a point inside will be directly proportional to small r. So on the axis the value of field will be 0. Up to the circumference, what happens is field is directly proportional to small r. Whereas field outside will be given by mu naught I divided by 2 pi small r. Field at a point outside is inversely proportional to small r. So when we plot a graph between field and a distance small r, it is going to be a straight line passing through origin up to the surface of the conductor, and outside should be rectangular hyperbola because field is inversely proportional to small r. So it is going to be option 2. Question number 31. The energy E and momentum P of a moving body of mass m is related by some equation. Given that c represents the speed of light, identify the correct equations. So if you look at this equation, there are involving mainly three terms. One is E, energy. Next one is a P, momentum, along with a c, which is nothing but speed of light. Next one, mass and speed of light. So we have to understand that the dimensional formula of energy and the dimensional formula of momentum into speed of light is equals to the dimensional formula of mc square. All these three quantities will have the same dimensional formula as that of energy, which is nothing but ml square t power minus 2. So because of this, the dimensional formula of E square and the dimensional formula of PC square, PC whole square will be equals to the dimensional formula of mc square. Therefore, it's going to be option 4. Question number 32. A solid sphere and a hollow sphere of same mass and of same radius are rolled on an inclined plane. Let the time taken to reach the bottom by a solid sphere and hollow spheres be T1 and T2 respectively. Then they are asking the relation between T1 and T2. So we know very well that whenever a body is rolling down an inclined plane without slipping, the acceleration of the center of mass is going to be constant. The acceleration of the center of mass of a body rolling down inclined plane will be given by g sine theta whole divided by 1 plus kcm square divided by r square. Now, due to this one, the time taken by the body to roll down through an inclined plane by distance L will be given by T is equals to under root of 2L divided by ACM. So as a result of this one, the total time taken by a body to roll down a distance L will be given by 2L divided by A. So we are going to get this equation as 2L into 1 plus KCM square by R square whole divided by G sine theta. And we know that for both these objects which are solid sphere and hollow sphere, the value of we are rolling them on the same inclined plane, L and theta are going to be same, and radius also is going to be same. So the value of time will depends on the radius of gyration. And we know that for a solid sphere, the value of kcm square divided by r square for a solid sphere is going to be 2 divided by 5, around 0.4. Similarly, kcm square divided by r square for a hollow sphere is going to be 2 by 3, which is around 0.67. So due to this one, the time taken by a solid sphere to roll down a inclined plane will be less than the time taken by a hollow sphere to roll down by the same inclined plane. So T1 should be less than T2. So when T1 is less than T2, so obviously this option 4 is going to be correct. Next. Question number 33. The output of the circuit is low for So here they have given a circuit involving the logic gates. You are asked to find out for what of these statements the output is going to be low. So what I am going to do here is we are going to consider that because this is a OR gate, the output from the OR gate is going to be A plus B. And here this is also for an OR gate, we have put a bubble. So the output is going to be, and we have joined both A and B. So the output, it will act like a NOT gate. So the output is going to be Z is equals to A plus B whole bar. A plus B whole bar. Of course, this can be also written as A bar dot B bar. So let us draw the truth table for this, and let us see what is going to be the output we are going to get. So if you draw the truth table, so x, y and z, the value of z is equals to A bar dot B bar. So when x is equal to 0, y is equal to 0, the value of z is going to be 1. When x is equal to 0, y is equals to 1, the value is going to be 0. 1, 0 will give 0. 1, 1 is also going to give 0. So here they are asking for what of the following, which of the following will give an output which is equal to 0. So when we relate this one to the concern truth table, now it's going to be the value we are going to get 0 output for the statement B, for statement C, and for the statement D. So the options are going to be here B, C, D only. Option 2 is going to be correct. Next question number 34. Which of the following figure represents the relation between the Celsius and Fahrenheit temperatures? So a graph is drawn between the Fahrenheit and Celsius. So if you want to draw the graph, first of all, we should know the relation between the Celsius and Fahrenheit. So when we consider the relation between Celsius and Fahrenheit, according to the principle of thermometry, it's going to be C minus 0 divided by the upper fixed point is nothing but 100 minus 0 will become 100, should becomes equals to F minus 32 divided by 180. So because we are drawing the graph between C and F, the value of C is going to be cancelling 20 on both sides. We are going to get 5 divided by 9 into F minus of 160 divided by 9. So when we plot a graph between C and F, it is going to be a straight line. So we have to understand that when the value of F is equals to 0, the value of C is equals to minus 160 divided by 9 degrees centigrade. And when the value of C will becomes equal to 0 when the value of F is equals to 32 degrees. So this particular equation will represent a straight line, which will be represented by the option 2. Question number 35. In the first configuration 1, as shown in the figure, 4 identical charges Q0 are kept at the corners A, B, C and D of a square of side length A. In the second configuration 2, the same charges are shifted to the midpoints G, E, H and F of the square. K is equals to 1 by 4 pi epsilon naught. The difference between the potential energies of the configurations 2 and 1 is dash. So they're asking the difference in the potential energy related to configuration 1 and configuration 2. So here this should be configuration 2, this should be, okay. So now let us solve this one. So this is about the interaction potential energy between the point charges. So here when we consider the first configuration, altogether there are 4 point charges. When there are 4 point charges, the total number of interactions will becomes equals to 4 into 3 whole divided by 2. So there are going to be completely 6 interactions. So we have to understand that there are 4 interactions between the point charges with a separation of small a, and there are 2 interactions with a separation of a root 2a. Similarly, when we take the configuration 2, there are again 4 charges, 4 point charges. So there are going to be 6 interactions. There are going to be 2 interactions separated by distance a, and there are going to be 4 interactions separated by distance which is equals to a divided by root 2. So if you look at this diagram, you can see these are diagonally opposite. These are 2 pairs, and apart from that, there are going to be 4 interactions due to the point charges lying at the adjacent corners. The distances here, similarly, if I take the second configuration, the distance between two adjacent charges is going to be A divided by root 2. So when we calculate the interaction potential energy, it's going to be like this. So the interaction potential energy related to the first configuration is going to be, I'm going to take K common, Q naught square I will take common. So in this one, there are four interactions due to the 2 point charges lying, a pair of point charges lying at the corners of a side. So that value is going to be, because I've taken Q naught square common, we are going to get four interactions, four pairs are there, divided by the distance is going to be A. Similarly, there are going to be two interactions, two pairs, due to the charges lying at the corners of a diagonal. So plus 2 times of 2 times divided by the distance is going to be root 2a. So from this equation we are going to get u1 is equals to k q naught square whole divided by a into 4 plus root 2. This is the energy, interaction energy associated with the first configuration. Similarly, the interaction energy associated with the second configuration is going to be k q naught square into 4. There are four pair of charges with a separation of a by root 2. So divided by a by root 2. Next, there are two pair of charges which are separated by distance of a. So from this equation, we are going to get u2 is equals to k q naught square divided by a is taken common 4 root 2 plus 2. This is going to be the interaction energy for the second configuration. Now in this one, they are asking what is the difference of the interaction energies. That means you are asked to find out what is u2 minus u1. When I take u2 minus u1, we are going to get this value as k q naught square divided by a is taken common. 4 root 2 minus root 2 will becomes equals to 3 root 2. Next, 2 minus 4 will becomes equals to minus 2. This is going to be the difference in the interaction energy between the 2 point charges. So if you look at these options, it should be k q naught square divided by a into 3 root 2 minus 2. It's going to be option 3. Next question, number 36. Arrange the following in the ascending order of wavelength lambda. So here they have given four wavelengths which are associated with electromagnetic spectrum. You are asked to find out the correct arrangement in which the wavelengths are going to increase, ascending order. So for this, first of all, we have to understand about the electromagnetic spectrum. When we consider electromagnetic spectrum, it's going to be something like this: gamma rays, X-rays, UV, visible, infrared, micro, and the last one is radio waves. So whenever we go up this one, the value of lambda is going to increase. Now here the wavelengths, so we have to consider the wavelengths. What we have to consider is microwaves, which is nothing but lambda 1 associated with that. Next, UV is given as lambda 2. Next one, infrared is given as lambda 3. And the last one is X-rays, which is lambda 4. Because this wavelength is increasing up this order, so when you are asked to find out the ascending order. I should start from lambda 4. So lambda 4 is less than lambda 2, should be less than lambda 3, should be less than lambda 1. So the order should be 4, 2, 3, 1. So it is option 3. Question number 37. So this is a statement based question where assertion reasoning are given. Assertion A is given as, in an insulated container, a gas is adiabatically strung to half of its initial volume. The temperature of the gas decreases. So first of all, we have to verify this assertion A. So because they have given that this is an adiabatic process, there is a relation between temperature and volume, which is nothing but TV power gamma minus 1 equal to constant. To have a simple idea about this, what we do is gamma minus 1 can also be written as a 2 by f, because gamma equals to 1 plus 2 by f. So from this equation I can write down T into V to the power of 2 by f should be constant. F is the number of degrees of freedom, which is a positive number. So from this equation we have to understand that T is inversely proportional to V to the power of 2 divided by F. Now as volume decreases, temperature increases. But in the statement A, they are given that in insulated container, a gas is adiabatically shrunk to half its initial volume, the temperature of the gas decreases. But here, as the volume decreases, temperature should increase. So the value of this statement A should be wrong. What about statement R? Free expansion of an ideal gas is an irreversible and adiabatic process. So when it comes to free expansion, it is an adiabatic process. So the statement A will be false and statement R will be true. So it should be option 4. Next question. The position vector of a moving body at any instant of time is given by R bar equals to 5t square I cap minus 5t j cap meter. The magnitude and direction of velocity at t equals to 2 seconds is. So they're asking the magnitude and direction of velocity. They're given the position vector. So let us consider the given position vector, which is nothing but R bar is equals to 5t square I cap minus 5t j cap meter. So when you want to find out velocity, instantaneous velocity is given by V bar is equals to dr bar by dt. That should become equals to 10t I cap minus 5 j cap meter per second. And you're asked to find out instantaneous velocity at an instant of time t equals to 2 seconds. So substituting t equals to 2 seconds, this value is going to be 20 I cap minus 5 j cap meter per second. So when it comes to the magnitude of this velocity, it should be mod v bar is equals to root of 20 whole square plus 5 square. So this value is going to be 5 root 17 meter per second. So when it comes to the direction, let us represent in the xy plane. So we can see that when it comes to the velocity, the x component is positive and y component is negative. So it's going to be in the fourth quadrant like this. This is the direction of velocity. So this is x, this is y, this is origin. So if I consider the angle made with the negative y-axis, this is theta. The corresponding x and y components are 20 and 5. So obviously we are going to get the value of tan theta. If we calculate, tan theta is equals to 20 divided by 5, 4. So theta will become equals to tan inverse of 4 with a negative y-axis. So the option is going to be 5 root 15 meter per second makes an angle of tan inverse 4 with a negative y-axis. So option 1. Question number 39. Young's double slit interference apparatus is immersed in a liquid of refractive index 1.44. It has a slit separation of 1.5 millimeters. The slits are illuminated by a parallel beam of light whose wavelength is 690 nanometers. The fringe width on the screen placed behind the plane of the slits at a distance of 0.72 meters will be dash. So here this is a YDSC experiment conducted in a medium. So they're asking about the fringe width. So fringe width of YDSC conducting in a medium is given by beta is equals to lambda of the medium into capital D is the distance between slits and the screen whole divided by small d. And we know that wavelength of light in a medium is given by lambda naught, wavelength in air divided by mu. So this value will become equals to lambda naught capital D divided by mu into small d. Fringe width is equals to lambda naught is wavelength of the light in air or vacuum, which is given, which is equals to 690 nanometers, 690 into 10 to the power of minus 9 into capital D is the distance between slits and the screen. It is given, which is equal to 0.72 meters whole divided by mu. The value of mu is given as 1.44 into small d. Distance between the two slits is given, which is 1.5 millimeters. 1.5 into 10 to the power of minus 3. 0.72, this will go 2 times. 2 into 1.5 is 3, and that 3 will go here 230 times. The value of beta is equals to 230 into 10 to the power of minus 6 meters. So it's going to be 0.23 millimeters. Question number 40. A solid sphere is rolling without slipping on a horizontal plane. The ratio of linear kinetic energy of center of mass of the sphere and the rotational kinetic energy is given by. So whenever a body is rolling without slipping, the ratio of translational kinetic energy to rotational kinetic energy is given by translational kinetic energy divided by rotational kinetic energy is equals to translational kinetic energy is half m vcm square whole divided by rotational kinetic energy is given by half ICM, moment of inertia about center of mass, into omega square. And whenever a body is rolling without slipping, VCM is equals to R omega, ICM is equals to M KCM square. So on simplification of this one, this value we are going to get as a R square divided by KCM square. So the ratio of translational kinetic energy to rotational kinetic energy is going to be R square divided by KCM square. We know that for a solid sphere, KCM square by R square is 2 by 5. So R square divided by KCM square will becomes equals to 5 divided by 2. Question number 41. A photograph of a landscape is captured by a drone camera at a height of 18 kilometers. The size of the camera film is 2 centimeter by 2 centimeter and the area of the landscape photographed is 400 kilometers. The focal length of the lens in the drone camera is. Now because here the object is having a square shape and film is also having a square shape. So what we can do is we can assume the object also to be having a square kind of shape. Imagining that this is something like a film, square film, and this is an object. So in between, this is the lens of the photo. So it's given that the distance of this particular camera, drone camera, from this surface, this is given as 18 kilometers. The area of this particular object is given, which is equals to 400 kilometers square. Whereas the area of the film is given as 2 centimeter by 2 centimeter. This distance we can take it as focal length. So as these two angles are equal, what we can do is we can compare the triangles. So when we compare the triangles, we are going to get F divided by 18 kilometers. 18 into 10 to the power of 3 will becomes equals to 2 centimeters. 2 into 10 to the power of minus 2 whole divided by 400 kilometers square, assuming it as a square. The length of each side is going to be around 20 kilometers. So 20 into 10 to the power of 3. So the value of F will becomes equals to 18 divided by 10 into 10 to the power of minus 2. So the value of focal length is going to be 1.8 centimeter. Option 4. Question number 42. A small uncharged conducting sphere is placed in contact with an identical sphere but having 4 into 10 power minus 4 coulomb charge and then removed to a distance such that force of repulsion between them is 9 into 10 power minus 3 newtons. The distance between them is. They given the value of 1 by 4 pi epsilon naught, which is nothing but 9 into 10 power 9 SI units. So you are asked to find out distance between them to have a force of 9 into 10 power minus 3 newtons. So whenever we consider two identical charge particles, one is charged, other one is uncharged. So when they are brought in contact, obviously because of same dimensions, what happens is the charge will be distributed uniformly. The charge on each of the sphere after they brought in contact will becomes Q1 will becomes equals to Q2 equals to total charge divided by 2, which is nothing but 2 into 10 to the power of minus 8 coulombs. So here you are asked to find out distance between the two charges if the force is 9 into 10 power minus 3. So using the Coulomb's inverse square law, F is equals to 1 by 4 pi epsilon naught into Q1 Q2 whole divided by R square. The value of force is given as 9 into 10 to the power of minus 3. 1 by 4 pi epsilon naught is given 9 into 10 to the power of 9 Q1, Q2 both are equal. 2 into 10 to the power of minus 8 both are equals to whole square, whole divided by r square. So this 2 and 2, 9 and 9 will get cancelled. So from this equation we are going to get r square is equals to 2 into 10 to the power of minus 8 whole square into 10 to the power of 12. So the value of r is going to be, r is equals to, I'm taking the square root on both the sides, 2 into 10 to the power of minus 8 into 10 to the power of 6. So the value of r is equals to 2 into 10 to the power of minus 2 meters. So r equals to 2 centimeters. Option 1. Question number 43. A particle oscillates along the x-axis according to the law x as function of time t equals to x naught sine square t by 2, where x naught is equals to 1 meter. The kinetic energy k of the particle as function of x is correctly represented by the graph. So x as a function of time they have given, the value of x naught is given as equals to 1. You are asked to find out the graph, related graph between kinetic energy and position x. So because the position is given by x is equals to x naught sine square of t divided by 2, the value of x naught is given as 1. So to find out the kinetic energy, we need to find out the velocity. So v is equals to dx divided by dt. I am taking x naught is equals to 1. When I differentiate this equation, we are going to get the derivative as 2 sine of t divided by 2 into cos of t by 2 whole multiplied with 1 by 2. So this 2 and 2 will get cancelled. So after this one, if you want to find out kinetic energy, then kinetic energy will be given by half mv square. So kinetic energy will becomes equals to half m. When I multiply the v square, we are going to get this equation as sine square t divided by 2 into cos square t divided by 2. So the kinetic energy, converting this equation in terms of x here, we are going to get this value as half m into sine square t by 2 is nothing but, because the value of x naught is given as 1, it should becomes equals to x, whereas cos square t by 2 is going to be 1 minus x. So looking at this equation, we can understand that the value of kinetic energy is 0 when x is equal to 0, as well as kinetic energy is 0 at x is equals to 1 meter. It is going to be maximum at x is equals to 1 by 2. Therefore, option 1 is going to be correct. Question number 44. The temperature of a body in air falls from 40 degrees centigrade to 24 degrees centigrade in 4 minutes. The temperature of air is 16 degrees centigrade. The temperature of the body in the next 4 minutes will be, it should be 4 minutes, should be printed, right. So this is a question which is based on Newton law of cooling. According to Newton law of cooling, delta T divided by time taken should becomes equals to minus of K into the average temperature minus temperature of the surroundings. So when I take the first 4 minutes, the temperature is changing from 40 degrees centigrade to 24 degrees centigrade. So 24 minus 40 whole divided by the time taken is 4 is equals to minus of K into the average temperature is nothing but 24 plus 40 divided by 2 minus the temperature of the surroundings is given, which is equal to 16. So from this equation, we are going to get minus 16 divided by 4 should becomes equals to minus of K into 24 plus 40 is nothing but 64 divided by 2 is 32. 32 minus 16 will becomes equals to 16. So from this equation, we are going to get the value of K is equals to 1 divided by 4. In the next 4 minutes, the temperature is going to start from 24 degrees centigrade and we have to find out the final temperature. So let us assume that the final temperature is T. So again, by applying Newton law of cooling, we are going to get T minus 24 whole divided by 4 equals to minus of K is nothing but 1 divided by 4 into the average temperature is T plus 24 divided by 2 minus temperature of surroundings is 16. So here this 4 and 4 will get cancelled. So now from this equation we are going to get t minus 24 should becomes equals to minus of t plus 24 minus 32. So t plus 24 minus 32 whole divided by 2. So on cross multiplying we are going to get 2t minus 48 is equals to minus t. 24 minus 32 is going to be minus 8. Minus or minus will become plus 8. So now from this equation we are going to get 3t is equals to 56. T is equals to 56 divided by 3 degrees centigrade. Option 4. Question number 45. An electron in a certain region of uniform magnetic field is moving with a constant velocity in a straight line path. Generally, whenever assertion reasoning questions are given, generally most of the cases A will be an independent statement. But here, in this assertion reasoning, they are given a statement A which is dependent on R. So we cannot judge this value of the validity of the statement A unless we read the statement R. What does statement R says? The magnetic field in that region is along the direction of velocity of the electron. So here he is saying that the magnetic field in that region. So he is specifying about the region what he has represented in the statement A. So in context with R, so if you imagine that the direction of velocity and magnetic field are same, then the statement is going to be correct. And related to the statement A, the statement R is going to be correct, and then R will be the correct explanation of A. So it is going to be A is correct, R is correct, and A is the correct explanation of A. So it's going to be option 3. Question number 46. The increase in pressure required to decrease the volume of a water sample by 0.2% is P into 10 power 5 Newton per square meter. Bulk modulus of water is 2.15 into 10 to the power of 9 Newton per square meter. The value of P is. So here they are given the decrease in volume, and you are asked bulk modulus is given, and you are asked to find out the increase in pressure. So an equation relating bulk modulus, change in pressure, change in fractional change in volume is nothing but bulk modulus B is equals to minus of delta P whole divided by delta V divided by V. Therefore, delta P should becomes equals to minus of B into delta V divided by V. So delta P should becomes equals to minus of B, bulk modulus. It is given in the question, which is nothing but 2.15 into 10 to the power of 9 delta V by V. So because there is a decrease in volume, we can say delta V divided by V is equals to minus of 0.22%, means 0.2 divided by 100. So minus of 0.2 whole divided by 100. So the value of delta P is going to be, from this equation, it's going to be 0. Minus minus will get cancelled, 0.43 into 10 to the power of 7. They have asked this value in terms of 10 to the power of 5. This should be equals to 43 into 10 to the power of 5 Newton per square meters. So the value of P is going to be 43. Question number 47. Acceleration due to gravity on the surface of the earth is small g. The diameter of the earth is reduced to 1/3 of the original value and the mass remaining unchanged. Then the acceleration due to gravity on the surface of the earth is. So the relation between acceleration due to gravity and the diameter of the earth is given like this. G is equals to G capital M divided by R square, but radius is equals to diameter divided by 2 whole square. Therefore, G is inversely proportional to D square. G2 divided by G1 will becomes equals to D1 divided by D2 whole square. This implies G2 divided by G is equals to D1 is a D, and according to the question, the diameter he said that becomes 1/3. So it should become D divided by 3 whole square. So G2 should becomes equals to 9G. So the answer is going to be 9. Question number 48. A string of length L is fixed at one end and carries a mass capital M at the other end. The mass makes 3 by pi rotations per second about the vertical axis passing through end of the string as shown. The tension in the string is dash. So you are asked to find out tension in the string. So first we'll draw the free body diagram of this particle. So the forces acting on this particle is, one is weight, which is equal to mg. Next one is the tension T. And because it is moving in a circular path, then what happens is we can resolve this tension into components. So the components are going to be T cos theta acting upwards, T sin theta acting toward the center. O is the center of the circular path. So now the relation between T cos theta and mg is T cos theta should be equals to mg. T sin theta will provide the necessary centripetal force. Let us imagine that it is moving in a circular orbit whose radius is equals to r. So T sin theta is equals to m r omega square. In the question, length L is given. The relation between length L and radius is sin theta equal to r divided by L. Therefore, T sin theta should be equals to m into r, can be written as L sin theta into omega square. Sin theta will get cancelled. Therefore, T should becomes equals to ml omega square. So now according to this one, T should becomes equals to ml into omega is nothing but 2 pi into frequency. The frequency here is given as 3 divided by pi whole square. So the value of T should becomes equals to 9 ml. So this will be equals to 9. The answer is going to be 9. Question number 49. The ratio of power of light source S1 to that of light source S2 is 2. S1 is emitting 2 into 10 to the power of 15 photons per second at 600 nanometers. The wavelength of the source S2 is 300 nanometers. Then the number of photons per second emitted by S2 is equals to dash into 10 to the power of 14. So you are asked to find out number of photons emitted per second by the second source. So the ratio of powers are given. We know that power is nothing but the total energy emitted per unit time. If I imagine that the wavelength of the light used is lambda, and if it is emitting n photons in t seconds, then P will becomes equals to n into the energy of each photon is nothing but hc divided by lambda whole divided by the time taken will becomes equals to t. N is the number of photons emitted in t seconds. So in this question, h and c are constant. Number of photons per unit time and wavelength are different. So now from this equation, the ratio of powers are given. The ratio of power of light of source S1 to that of source S2 is given as a 2. So what we can say is P1 divided by P2 should becomes equals to N by T of 1 divided by N by T of 2 into, it is inversely proportional to wavelength, so lambda 2 divided by lambda 1. P1 by P2 is given as 2. That should becomes equals to N by T of 1. So number of photons emitted per unit time by the first source is given as 2 into 10 to the power of 15 whole divided by N by T in the second case into ratio of wavelengths. Anyhow, this is a ratio of wavelengths. No need of converting the units. The value of lambda 2 is given as equals to 300 nanometers divided by lambda 1 is given as 600 nanometers. 2 and 2 will get cancelled. 2. So now from this equation we are going to get number of photons emitted per unit time. In the second case is equals to 10 to the power of 15 whole divided by 2, which is nothing but 5 into 10 to the power of 14 per second. So the answer is going to be 5. Question number 50. A tightly wound long solenoid carries a current of 1.5 amperes. An electron is executing uniform circular motion inside a solenoid with a time period of 75 nanoseconds. The number of turns per meter in the solenoid is a dash. So here mass of the electron is given, which is 9 into 10 to the power of minus 31 kg. Charge of the electron is given 1.6 into 10 power minus 19 coulombs. Mu naught is given 4 pi into 10 power minus 7. 1 nanosecond is given as 10 power minus 9 seconds. So whenever any particle is moving in a perpendicular magnetic field, the time period is given by T is equals to 2 pi m divided by qb. Because it is moving in a magnetic field produced by a long solenoid, this value will becomes equals to 2 pi m divided by q into b is nothing but equals to mu naught ni. You are asked to find out number of turns per unit length, so small n will becomes equals to 2 pi m divided by q into mu naught into I is the current into time period, which is equals to t. So this value will becomes equals to n is equals to 2 pi into m, mass of the electron is given as 9 into 10 power minus 31 whole divided by charge of the electron is given as 1.6 into 10 power minus 19. Mu naught is given, which is nothing but 4 pi into 10 power minus 7 into the current is given 1.5 amperes, and time period is given. The value of time period is given as 75 nanoseconds, 75 into 10 power minus 9. So this will go 2 times. 2 into 1.5 is 3. 3 will go 3 times. 3 25 times. So the value of n is equals to 10 to the power of minus 31 whole divided by 1.6 into 25 is nothing but equals to 40 into 10 to the power of minus 19 minus 9 minus 28 minus 28 minus 7 is nothing but minus 35. So the value of n is going to be 10 to the power of 4 whole divided by 40. So this should become equals 1000 by 4, which is nothing but 250 turns per meter. Thank you.